Hi, my name's Dean Kershaw, Kershaw Instrumentation, and we are here today to talk about Inkometer conversions. What I have here in front of me is a recently converted Swing Albert model 106 Inkometer. After the conversion, it becomes our model E2006U. We also provide this conversion for the older model 101, which would become an E2000U. Now, if you recall, on these model 106s, the original machine utilized a control panel such as this, with some controls on it. And then within the machine, there were a number of printed circuit boards, power supplies, connectors, and so forth that were often problematic in the field in terms of operation. So what we've done is we've eliminated all of those electronic components, and we have replaced them with one simple device, being this flat screen PLC. All of the connections and the signal conditioning and all the control features go through this device, and we're going to talk a little bit more in detail about this. Now, this discussion I've actually broken down into two segments. The first segment is just going to be a quick overview of the operation of this machine. And if you have a older machine, either a 106 or a 101, hopefully you'll have a good overview of what we can provide for you in terms of the conversion. The second part of our discussion is going to be a more in detailed look at some of the features, the calibration features, and some of the other areas that are involved with the flat screen. In addition to the conversion, we also supply a printer option, which will give you a printout of the data during the test. We're going to actually demonstrate that in the second portion of our discussion. Now, if you recall, on the original 106, there was a printer in this area. We've eliminated that, and we supply a simple point-of-sale cash register type printer. The nice feature about that is the ink ribbons and the paper are readily available at office supply stores, and if the printer ever fails, you can simply just buy a new one and plug it in. We also have a computer interface for this, which allows you to plug this machine into your PC, and you can generate time versus tack curves when you run your test. You can store the data. You can superimpose one test over another. That becomes very useful, especially when you're testing the process colors, because if you're running the 4 or 5 process colors, you can now plot a red plot over a blue plot over a black plot and so forth. We're not going to have any discussion on the computer interface on this demo, but if you are interested in finding out more about that, we have literature that we can send you. We also have information on our website. The computer interface is available for either the E2006 conversion like we have here, or the E2000, or any of the TACmaster devices that we make. Essentially, it's the same computer interface for all. Now, what I'd like to do, starting our first segment of our discussion here, is I want to go over the operation of this machine and show you all the nice things that the PLC provides for us. So I'm going to move over to the other side here. When we first power this machine up, we're going to get to the manual display that looks like this, and it is exactly as you would expect. Essentially, you can manually operate this machine from the screen. Now, we have a couple features here. We have a tack display, which you're going to see active in a moment. We have a speed display. We can zero the tack from here simply by pushing this button. And we have the standard speed controls. We have a low speed adjust. We have a high speed adjust. We have an auto start, which we're going to talk about in a moment, and we have a stop. Now, to adjust the speeds, for example, if we want to set our low speed to 400, we just simply touch the display here, and we key in the desired speed. I just keyed in 400, and now our low speed is set for 400. We can do the same thing on the high. Now, to demonstrate, I'm going to put the rolls down, and if I push the low speed, you'll see this thing is now operating at 400 RPM. Our tack display is alive, and we'll just let that settle for a moment. If I want to tear the tack display, I just touch the 0 here. That'll send that back to 0. And you can see if I move the top roller, we get a tack reading. And if I let it go, it goes back to 0. Now if I want to change the speed to high speed, I just simply push this button here. And it's going to go up to high speed. Now we're operating at 1200. And if I want to go back to low speed, I just touch that again, it'll go back to 400. And if I want to stop, I just push the stop button, and that stops all the motion. The manual screen is very simple. If you just want to run a quick test, you can come into this manual screen, put the ink on the roll. I can distribute it at low speed, like so. And I can allow it to distribute for a few seconds, and then I can kick it up to high speed and start my timing process. And at the end of 1 minute, I look at the tack data and get my tack results, and then I can go back to low speed to clean the rolls and stop the test. That was a very quick explanation, but I think it's relatively straightforward. Now, we'll talk a little bit about the automatic feature of this machine. The way the automatic works is, if I start the automatic feature, what it's doing now is it's distributing. Let me back up here for one moment. If I'm going to run an automatic test, what I'll do is I will apply ink to the rolls, which we're actually going to do in a couple of minutes here. And we push the start button. And now what it's going to do is it's going to distribute that ink at 200 RPM. And it's counting down here, 3 seconds, 2 seconds, 1 second. And now it goes up to 1200, our operating speed. And now we're counting up in seconds. And that process will continue until either I push the stop button or it times out at 1 minute. So I think to provide a better demonstration of this, what I will do is I will actually run a, let me actually run some ink on here, and I will explain to you what's happening as we go along. So I have an ink sample prepared here. So I'm going to put this ink on the rolls. Now, just FYI, I have set my my automatic parameters so that it will distribute the ink for, I believe, 10 seconds at 200 RPM, and then it's going to ramp up to 1200. It's going to run for 1 full minute, and then it will automatically shut off, as I will demonstrate here. Now, all of those setup parameters that I just discussed in terms of the test time and the test speeds are all set up from another screen, which we'll discuss a little bit later on in the second portion of this. So without further ado, I'm going to go ahead and start this automatic test. Now what's happening is it's running at 200 RPM to distribute the ink, and our distribution is counting down. All right, now we've started our test. It's going up to 1200. You can see the ink is distributed. Our printer has printed out the header. And now every 10 seconds, it will take a tack reading and it will print out the results over here on the printer. So we're going to go ahead and we'll let this run for a little bit. Okay, so I had programmed in a 30-second test. So the 30 seconds has elapsed. And you can see the test stop by itself. And what it does is it has gone down to what we call an idle speed. The idle speed is set around 100 RPM. Now the only purpose of the idle speed is if you start the test and you walk away to do something else, we don't want the machine to stop and have the rolls stationary. So this is just, as it says, it's just running the rolls at an idle speed to keep them turning until the operator can come back and terminate the test. Now if you look over here, I have a printout of the data, and it's telling me what the tack and the speed were at 10 seconds, 20 seconds, 30 seconds, and so forth. All of these features and these time sequences that we've discussed are all programmable through this panel, and we're going to talk about that in the second part of our demonstration. Now also, one other thing I want to point out for you, and we'll talk about this in some more detail in the second part of the demonstration. You'll see up in the top right corner a little green box, and it says Ink Cow. What that means is that when we calibrated this machine initially, before we started this demonstration today, we used an ink to calibrate the tack numbers that we're getting on the machine. We used the tack standard ink. Now, in addition to that, we also have what's called a dry cal, which would be a box over, I guess it's in the same place, but it's a different color. Now, the dry calibration, that's a calibration using the calibration weights that you may be familiar with. Now, one of the niceties of this machine is we have the ability to calibrate using the weights and storing that information. We have the ability to calibrate using a tack standard ink of your choice and storing that calibration data. And you can select whether you want to run your test based on the weight calibration or on the wet sample calibration. I believe this will conclude the first segment of our discussion, and in a few moments I will be back and we're going to talk in some more detail about some of the other features that are involved with this machine, including the calibration. So if you are interested in finding out about the calibration and setting up some of these parameters as I demonstrated here on the test, then I would suggest that you review the second portion of this demonstration. We're now ready to begin the second part of our discussion on the Inkometer conversion model E2006. If you recall, in the first segment we ran a test using some ink and I demonstrated the features of both the manual test mode and also the automatic test mode. What I want to do now is we're going to go through each of the screens on this PLC, and I will describe to you in some detail in terms of how to operate these screens, and also we're going to do a calibration on the machine, and I will show you how the process of how the machine will walk you through that. One comment that I want to make before I begin is you'll notice on many of the screens there'll be a question mark, usually in this top corner. By pressing that question mark, it'll take you into a help screen, and there's usually several pages on each topic, and then when you get to the end it'll take you back. So most of the topics that we're talking about here in our discussion you will have access to later on simply by using the help text through the question marks. You'll see that question mark on a number of the screens. Okay, we're going to talk first about the mode screen. You'll see from our manual operation screen, this button here takes us over to the mode screen. The mode screen is kind of the root of this system, and from the mode screen we can get to various places within the system. We're going to look at the test panel first. It's very simple. If I bring the test panel up, this is merely a troubleshooting device, and what this allows us to do is if there's something on the machine that is not working properly, we can go into this test panel and this will help us troubleshoot the problem. For example, if I push and hold this, it'll just jog the motor slowly, and you can see our speed control is shown here. So that tells us that the motor is working properly and our speed sensor is working properly. If I put this top roller down, you'll see our tack meter should move. We can tear that. We can untear it by doing the reset. And we even have provisions where we can check to make sure that the printer is working properly by pushing these buttons that'll print out the data as described. Again, this is simply a troubleshooting tool. Under normal operation, you really wouldn't have any reason to even access this test panel unless you suspect that you have a malfunction with your machine. Now we're back to the mode select. The green button here, of course, is the test we already talked about in the first segment, but that will jump you through to the manual operation, and from the manual operation I can get to the automatic operation as I had demonstrated in the first segment. So I think we've enough described there. The calibration I'm going to get to last because that's probably the most involved part of it. Let's take a look at the yellow button, which is the test setup. We have this password protected so that you may not want every operator to be able to get in and access the information that's in the test setup area. Again, you'll see the question mark, and I can go through the various screens there that will hopefully describe this in some detail. Now on the test setup, it's exactly what it says. This is where we're going to set up all of the parameters for actually running the test. We'll talk about each one of these. We have a temperature display. On some of these models, we supply an external temperature sensor that measures the water bath temperature, and some of them we don't. So this button here allows us to turn that temperature display on or off. Obviously, if we don't have the display, we turn that off. If we do have the temperature sensor, then we can turn that on and a temperature display will appear on the test screen when we actually run the test. Now you'll remember from the first part of our demonstration, I mentioned about an ink standard calibration versus a dry calibration using the calibration weights. This is where I select which one of those calibrations that I choose to use for this particular test. If I'm in the dry calibration mode, all it's going to do is it's going to bring up the calibration factor that was generated in the calibration section of this, and it's going to run the test based on that. If we choose an ink calibration, we turn that on. Now you'll see there's a number here which just happens to be keyed in 1, 2, 3, 4, 5. What that is an area when you actually do the calibration with the ink, it allows you to key in a product number or a lot number as a reference for the ink standard that it was calibrated to. For example, if you were to hand me an ink and it had a lot number of 1122 and you wanted to use that as your calibration standard, when we go through the calibration, which we're going to do in a little while, there's a section there where I can key in that 1122, and the number over here, that's the actual tax standard that we adjusted it to. So if there's ever a question as to what ink standard was used for the calibration and what the ink standard number was, that information essentially is generated right here on this line. So you'll get a better understanding of this when we actually go through the calibrations. Now the memory and the printer on. If you recall, when we ran the automatic test a little while ago, every 10 seconds you would hear a beeping sound coming out of here, and we would get another line of data over here, and it would latch the TAC number on the display until the next timeout. Well, this is where we're actually setting the timeout. If I wanted to have this thing print every 30 seconds, for example, I would just touch this, I would key in the time interval that I want, and now I've changed my time interval to 30 seconds. So what I've just done now is when we run a test, it's only going to print out every 30 seconds instead of every 10 seconds, and also the meter on the panel is going to update every 30 seconds. Now if I want just a live display that's active all the time and I don't worry about the print, then I can just simply turn the printer off, and now the printer function goes away altogether. Okay? The auto test, if you recall, when we ran the auto test, we did a distribution of 200 RPM. Well, if you look here, this is where that 200 RPM came from. If I wanted to change my distribution speed, I would key that in here. Our actual test speed was at 1200 RPM, and this is where I've keyed that in. Our distribution time, if you recall, when we ran that automatic test in the first segment, it distributed the ink for 10 seconds, and I make that setting here. And we ran for 30 seconds or a half a minute. Normally, these tests run for 1 minute, so we'll make that 1 minute as a test time. So what that means is when we go into the automatic mode, it's going to run for a full minute, and then it will shift down into that slow idle speed like we saw in the first segment of this. Now keep in mind, we can put large numbers, 20, 30, 40 minutes into this test time. So if you want to run a misting test or some type of a stability test, you can run this for an extended period of time. So anyway, this is where we set up all of our test parameters for use in the automatic test mode. Now the other area of interest is we have these advanced settings, and what the advanced settings are is when we actually do our calibration, which we're going to do next, this is where we key in all of the parameters for our calibration. For example, we're going to do our dry calibration only at 400 RPMs, and we're going to wait 30 seconds. What's going to happen in a dry calibration, I don't think we're actually going to do this for this demo because it's very straightforward. But when you start the dry calibration, it's going to tell you to put the calibration rig on the machine and then apply the weights at certain intervals. And what this is telling us is that it's going to wait 30 seconds between each one of these intervals as we apply the weights. The second line here is for the ink calibration. When we do a wet calibration, which we are actually going to do using an ink sample, we're going to distribute the ink at 250 RPMs for 15 seconds. Again, this is almost like the automatic test. We're going to do our actual ink calibration at 1200 RPM, and we're going to wait 60 seconds before we enter that data because the tax standard is usually a 60-second test. So that's where we're going to want to do our calibration. And then when we're all done, our idle speed is going to go back to 100. Now the tack reset. The purpose of the tack reset is when we build these machines in the factory for the first time, we'll actually calibrate these using tax standard inks and ensure that they are calibrated properly. Well, then what we will do is we take those numbers that we generate and we actually hard code them into this PLC so they don't go away. Now, in the event that you get totally lost on your calibration or the calibration is just completely out of whack, all you're going to do is push that tack reset, and that's going to set this machine back to the factory default. And that's essentially what this is telling you here, is that by pressing this, that we're setting the dry calibration back to our factory standard. So that's just a good feature if there's ever a question about your calibration, you can set it back to the factory settings and start over. All right, the last section of the touchscreen is the calibration, and again, we have this password protected because you don't want the operator necessarily to get in and be able to change your calibration. We have 4 different areas for the calibration. We're going to talk about 3 of them, and then we're actually going to perform the 4th one. The temperature calibration is actually very straightforward. I had mentioned a few minutes ago that we sell a external temperature probe that will measure the water temperature and display it on the screen. All the temperature calibration is going to do is it tells you to set your, in fact, we'll just walk through it. What it's telling you to do is to set your temperature bath to 90 degrees Fahrenheit, because that's the standard operating temperature for this machine. So you're going to get a thermometer, hopefully something like a digital thermometer that's NIST traceable, so we know that it's accurate. And when we're sure that that water temperature is at 90 degrees, then we just simply press that, and now it's going to take whatever information is coming from our temperature probe and set it to 90 degrees. Very simple. We didn't make the calibration any more complex than that because we're really only operating around 1 point. So that is certainly suffice. Now the speed calibration. The speed calibration is something actually that the customer doesn't have to worry about unless the machine has been taken apart, or the motor control has been changed, or the motor has been changed, or something drastic has been done to the machine. Within this machine, within this PLC, there is an algorithm that when you're actually running a test, what it's doing is it's checking the speed every 2 seconds, and it's making an adjustment as necessary, and it's holding it within 5 RPM of the target speed. For example, if we have our operating speed at 1200, it is expecting the speed to be somewhere between 1195 and 1205. Now what happens is every 2 seconds it goes out and it looks at the speed. If the speed is within that plus or minus 5 RPM tolerance, then it does nothing. But if the speed for some reason should drop below the 1195, then it'll just speed it up ever so slightly to bring it back into within that acceptable range of speed. And of course, if it goes over the 1205, it'll reduce the speed by a little bit for the same amount. Now, with that being said, when we first turn on this machine, this thing has to know approximately where that target speed is so that it can get very close to that target speed the first time around. Otherwise, it's going to keep hunting and hunting until it gets the speed within range. So also speed calibration is going to do is the first time when we put these machines together, we go through the speed calibration and it runs through a whole range of speeds, and what it's doing is it's essentially making a map of what the signal levels coming out of here are compared to what speed the machine will actually operate. Now when we tell it that we want it to run to 1200, it will know precisely what signal it has to output to the motor, how much current it has to send to the motor to get it to that 1200. So what it's going to do is it's going to send the appropriate current to get the motor running at the proper speed, and then every 2 seconds it's going to check, and it's going to make very small adjustments. So with that being said, the speed calibration, it really only needs to be done that first time to get all of the speed in check, and at that point the automatic speed control, which is always active in this machine, essentially will take over. The dry calibration we're going to talk about, but I don't know that it's really necessary that we go through the whole procedure. But the way the dry calibration is going to work is when we start the dry calibration, it's going to tell us to install the calibration rig, and there's even some photographs that show how that rig is installed. Then what it's going to do is with the rolls turning, it's going to check for 0, and of course the 0 is going to be with the rolls turning with no ink and the ink dry, so you have no tack on the rolls. Then it will tell you to insert certain weights onto the test rig, and now it will figure out what the signal levels coming in are in relationship to those weights. And at that point, once you complete that dry calibration, it'll now store those parameters, and anytime we run an automatic or a manual test using the dry calibration, it's going to be in comparison to the data that was generated during that dry calibration routine. Now the ink standard calibration, we're actually going to run through this now, and I'll show you how it walks us through. So if I go to the ink standard calibration, I'm going to read what it says to you here. It says leave the rolls dry, lower the top roller to the brass roll, and engage the vibrator roll. Press the calibration button to continue. Beware, the rolls will begin to turn. Now we've got a little time out here that's telling us how much time will elapse before the next step. Now what it's doing during that 30 seconds is it's just letting this thing stabilize with no ink under dry conditions and making sure that everything is absolutely rock solid. Now when this reaches 0, it's going to take that reading off the top roll and call that our 0 reference point. Okay, so that's done. So now our 0 has been established. Now I'll read this screen. It says carefully fill the pipette with the proper amount of ink with your standard ink. Well, I have a pipette here, so we're going to go ahead and I have an ink standard tack here. So we're going to put this on a distributor roller only, and I just give that maybe just one turn to get the bumps out. Now it says enter the tack standard ID number and the tack value below. Let me explain. This particular ink has a lot number of 1, 2, 3, 4, 5, 6. Okay, so I've now entered 1, 2, 3, 4, 5, 6. So if you recall, when we go back to that auto setup screen, it will tell us, it will remember that number. So in the future, if there's ever any question about what tack standard we've used, it'll be as per what we've keyed in here. Now this particular ink has a tack of 16.5. So we're going to put in 16.5 because that's what we want this machine to measure this tack. Now it says press the continue button to proceed. Be aware that the rollers will begin to turn. Now what's going to happen is it's going to distribute the ink at the numbers that we keyed in that auto setup screen. It's distributing ink, it's counting down. All right, now it's beginning the actual test process. And you can see it's counting down. We have 53 seconds left. Now this is not doing anything at this point other than just running the ink out for a full minute, just as we would do in a normal test. And we're going to stand here for another 30 seconds or so, and we're going to wait for this to complete. And 10 seconds left. Now what's going to happen when this reaches 0 is going to look at the tach value on that top roller, and it's going to set that to 16.5 because that's what we keyed in, okay? So it's telling us that our calibration is complete. And at this point, we don't have any idle speed here because the assumption is that the operator is going to be standing by doing this calibration. Means that it only takes a minute. So they're not going to leave the rolls in a stationary position for very long. So our calibration is complete, and it takes us right back to our manual screen. And we now can run this thing at low speed, and we can clean the ink off. Now you'll notice here that we have, it's telling us that we're running we're running a test based upon our ink calibration. And from this screen, we can come over here and we can actually start a test. Now, obviously, I should have put new ink on the rolls, but for demonstration purposes here, you can see we're in the distribution process. And now we're going to ramp right up to our 1200 operating speed. And you'll observe on our tach display, there is our 16. We were looking for a tach of 16.5, and we're right there. So that means that our calibration was successful in terms of what we did. Our numbers are dropping a little bit because our ink started to dry out. So I'm going to go ahead and terminate this test because we had gone through that. Process earlier. Now again, here's our printout over here of the printer of our results showing what our tach value was for that little quick test that we ran. And I believe that concludes our presentation on this device.